Good morning everyone, my name is Colin and today I'm going to talk about partial derivative. So partial derivative basically is to show how a function changes with respect to one variable while keeping another variable constant. So let's look at the example. So fxy is equals to x squared plus y squared. So from here we can notice that there's two variables which is x and y in the function. So and the question states that while respect to x, so we can know that our y is equals to constant. So our constant is equals to 0. This is because the rule of derivation, our constant is always be 0 in derivation. So our y is equals to 0. And the derivation of x squared is 2x. So from this, we can know that our answer of df over dx equals to 2x. So next, let's talk about the difference from ordinary derivative. So it is used when there's only one variable. So what's the difference between partial and ordinary, which is the partial is only used when there are two or more variables, while this ordinary is only used when only one variable. So let's look at example. So fx, you can see there's only one variable which is x only. So we just make a simple derivation which is dy over dx equals to 2x. So let's look at back to the partial example. So from here we can notice that there's two variables which is x and y. So the answer is going to be same. So why? I know you guys will ask why. Yeah, it's because the y is not inside the x, while the question is respect to x. So in that case, our y is seem to be constant. But if our y is inside the x, it's going to remain to the same value. So let's see some example. So from here, the first question, we notice that it has two variables which is x and y. So we also notice in the equations is equals to 3x squared y plus 2y. So the y for the first part is inside the x, which is the y will remain as the same value, while the 2y will become a constant because it's not in the x, because the question is respect to x. So from here, the df over dx, you can notice that it only have the derivation of a 3x squared and the y remain as the same, and the 2y is equals to constant, so which is 0. Well, when you're finding the df over dy, which is the respect to y, you will notice that the y will become to 1. It's because the differentiation of y is equals to 1. So the 3x squared is remain to the same because it's inside the y, while the 2y is equals to 2 is because y is equal to 1. So it's become 2. So the df over dy is equals to 3x squared plus 2. So let's look at the more complicated question. So from here, you can notice that it has three variables, which is x, y, z. So from here, we know that we only can use partial derivative because they have two or even more variables in the equation. So for the first, this is respect to x. So the answer is going to be z. It's because the x is equals to 1, while the y squared z is turned into the constant. So only the z remain its own value, while others like y squared z is equals to 0 because it's a constant, and x is equals to 1. So let's see what happens if it's respect to y. So from here, we can know that the answer is 2yz. Is because the x is equals, the xz here is become the constant, so it's going to be 0. So then the differentiation of y squared is equals to 2y. And the z, because it's inside the y, so it remains the same value. And same as the third one, respect to z. So from here, why the answer is x plus y squared is also because the z is equals to 1, while x remains the same value because it's inside the z, while the y squared also remains the same value because it's inside the z, and the z is equals to 1. So the answer is x plus y squared. So next, I'm going to tell you about the real-world engineering application. So why this differentiation is important for our engineer is because it can help us to calculate the variables that we want, such as heat distribution in a metal plate. So from here, the temperature T, X, Y, so it can depends on the position. So let's say if it is respect to X, which is we can find that how the temperature changes in x direction. So same, if I'm doing dt over dy, we can find out how fast temperature change in y direction. So summary of the importance. So it helps engineering understand and control system involving multiple changing variable. So there's example what we can calculate from here, like temperature, stress, or pressure for so it can be a better safety or efficiency for engineering, just like this, the temperature. So thank you. I think today is all